Hello, everyone, and welcome to the Engineering Moments podcast, where we talk about software development teams from a leadership lens. Today, we're going to be talking about the evolving role of data engineering. And with me, I have Baron. Baron, would you like to introduce yourself?
Thank you, Hugo. My name is Baron Ntambwe. I'm a software engineering professional. I've been in management, served in different capacity. So recently I've been involved more into AI and big data. And today we'll be trying to share a little bit of insight in that specific domain.
Awesome. Thank you so much for that intro. So, I think the best place to start for me is data engineering. It's grown a lot, and I think that there's still a lot of people who don't understand the big difference between data engineering, and software engineering. So, what are the big differences for you between the two, especially in terms of skill sets or just how you think about how you approach each one?
Yeah, I think data engineering is one of the new software engineering specializations that emerge from the traditional database development we used to know a few years ago. So the main difference between data engineering and software engineering is the fact that in data engineering, we try to capitalize on software engineering principles to implement efficient and high performing data pipelines. So we cannot dissociate the concept of data pipelines with the concept of data engineering. Data engineering is fundamentally about building data pipelines that has to deal with very high volume of data, whether in batches or in real-time streaming. Having said that, whatever skills we have in software engineering, like writing code that is readable, is scalable, taking in consideration the architecture and how it will evolve over time, we're still applying the same principles in data engineering, but we are just solving a different set of problems.
Cool. And in terms of the skill sets that you need, um, are there any big differences?
Yes, there is a big difference because as data engineering evolved from the traditional database development, a data engineer is expected to have a very advanced level of SQL server language. So they should be able to compose very complex queries during the implementation of any process that manipulates data in a very complex way. And also in terms of infrastructure, there is a high expectation from the data engineer to understand all of these platforms that are allowing to implement high performance computing in the context of data engineering, such as Hadoop, Apache Spark, and all other all other tools that implements the MapReduce pattern or multi-stage SQL query injection pattern. A software engineer will know how they work, but they don't have, they don't usually have that level of expertise that is required from a data engineer.
Okay, thank you. That was really, really helpful. Now, staying on the theme of the differences within the software development environment, you have product managers, you have product designers, you have software developers, and that work together in that space. Now, from my understanding of sort of data engineering, you have data engineers, you have data scientists, and sometimes you even have ML engineers. How do you what's the best way to if you have these various disciplines within your team, what's the best way to get them to work together, and what are some of the different focuses? For example, what's the difference between a data engineer and an ML engineer? And then what's the difference between what a data engineer will do and what a data scientist will do?
Yeah, so the best way to work with these different teams is to start first by considering them as complementary to each other. So they are not essentially mutually exclusive, but they complement each other. The software engineers will build the business logic, the user interface or the user experience. The data engineer will provide the bedrock, all the data that will be required for that specific business logic to function. And the machine learning engineer will implement the algorithm to provide insight in terms of predictions or in terms of discovery or root cause analysis or anomaly detection. So they are working to solve the same problem, but on different facets.
Okay?
This
And what
one,
about the data scientists?
data scientists, they usually operate together with machine learning engineers. So in terms of production development, personally, I don't see the need of a data scientist if we have a machine learning engineer,
Okay.
because the main role of a data scientist is to investigate and find new ways of solving problems, while a machine learning engineer leverage the theory and tools that exist already to solve problems at scale. So a data scientist provides the theory, maybe a proof of concept, how it can work, but the engineer now builds a real solution that solves a real problem at scale.
Okay. So how do you know when you have a great data pipeline from like from a leadership point of view? How do you measure that?
Well, on the leadership point of view, personally, I leverage a set of KPIs or key objective results. So the first one has to do with the correctness of the pipeline themselves. So if we say they need to extract from a specific data source, they need to transform to bring the extracted data into a specific format, and they need to load it in a conception layer. So it needs to do exactly what it was specified to do. So if it's doing half or it's doing it but not covering all the edge cases, that is not a great data pipeline, because it will cause a lot of problems in production and waste a lot of time trying to figure out what went wrong and conducting lengthy root cause analysis. So that's the first step, the correctness of the logic at the extraction level, transformation level, and the loads level. The second aspect is the implementation of abstractions. As I mentioned earlier, data engineering is software engineering applied in the data domain. So whatever we expect from the software engineering side in terms of engineering practices that need to be used when writing code or designing modules, we're expecting them as well in engineering. That's the piece that I've been missing a lot, because initially many of the data engineers were mathematicians and statisticians who transitions into IT. So they didn't have any engineering foundation. So the code I've been writing was a lot of spaghetti codes per se. So personally, when hiring data engineers, I usually make sure that they really understand engineering principles as well, because they need to respect all the abstractions. They need to respect the principle of encapsulation, all the solid principles, dependency injection, all of that. So that makes the codes more maintainable. Imagine we have thousands of data pipelines doing ingestion job across the organization, and we don't write it in an efficient way. It causes issues. So we need to be very systematic, also using design patterns whenever required, so that we ensure the correctness of the codes we are writing to implement those data pipeline. Another aspect which we need to take in consideration is quality. So we need proper unit testing and integration testing, just the same way we do it in traditional software engineering. and also data quality check, ensuring that we are consuming the right data and the data we are consuming is consistent enough. For example, if we are consuming data from different data sources, this data, for example, the dates start with the month and then the year and then the day, and somewhere else it starts with the day, the month. So it will cause a lot of issues when starting using it in the business context. So ensuring that we implement very strong data quality checks will allow to build a very robust data pipeline that will respond to the business need. And the last layer of endeavor is monitoring and alerting. Because when we talk about a great data pipeline, is the one that respects the service level agreement. If we tell the clients that your data will be refreshed every morning at 8 a.m., that need to be done at 8 a.m., not at half past. So when we have issues with the data pipeline, we need to be notified in a timely fashion so that we can intervene and correct the issue as soon as possible so we can respect the service level agreement. So the better way to achieve that is to have a very strong monitoring system and alerting system. And at architecture level, of course, the architecture needs to be scalable. If the data ingestion can work with 500 parallel nodes executing the same job at the same time. And when the workload increases, we should be able to go to spin up thousands of parallel jobs to work on that specific job to make sure that the processing does not suffer in terms of performance so that the service level agreement can be respected. And also availability. We need to ensure that we have enough redundancy so that our architecture can be available all the time in case of any material failure in the system. So this is the attributes of a very great data pipeline.
Okay, thank you very much. I particularly like what you talked about, what you mentioned about the scalability, because it sort of aligns with my next question. Now, machine learning and AI have become a lot more mainstream, right? Now, have you noticed any, or have you experienced any sort of changes or any improvements in how we build data pipelines to support these sort of systems, at scale, or just fundamentally, has any of the thinking changed, even if it's something that you do personally or you think might help? Be interested in getting your thoughts on that.
Yes, a lot of things have changed, especially at the mindset level as well as in practice, because AI became mainstream because of big data. AI have been existing since the World War One, World War Two, but it was not a big thing because we didn't have big data. And in this age of information, data is available and is growing at a very high velocity. Then it empowers the existence of AI. So that has very strong implications in the way we work as engineers. For example, we have to shift our mindset when designing the data layer. It's now compulsory to think upfront about handling many different data sources. So when we're designing a data lake, we are not designing just for relational database like before. We'll just save data which could come maybe from Oracle or from SQL Server or from Postgres. That era has passed a long time ago. Now we are thinking in terms of structured data, non-structured data, and semi-structured data, which means we should be able to handle data like emails, for example. We should be able to handle social media feed. We should be able to handle application logs. We should be able to handle network traffic. We should be able to handle structured data, traditional SQL data. We should be able to handle non-SQL data as well that can be stored in object storage like S3 buckets, for example. So when we are building that data layer, we have that in mind in terms of the architecture. We implement our abstractions in such a way it can evolve easily without causing any ripple effects in the design that are being done already. So if we are today, the needs right now is to deal with NoSQL, to deal with unstructured data source. And tomorrow we have to deal with structured data sets. Then we just need to plug in the new configuration and the architecture should be able to work instead of rewriting the code, changing things, redeploying everything again, wasting a lot of time. So that is the first aspect of some of the shifts that have been happening. And the second one is to always have in mind that in terms of data processes, we plan upfront for batch processing and stream processing. Before it was not like that. Before most of the things used to happen in batch processing, we never care about streaming. Even when we implement streaming, it's usually at the API level using message buses like Kafka or RabbitMQ. But now we have to leverage very powerful high performance computing tools like Apache Spark, which can allow us to ingest data in real time, especially for machine learning purposes, to be able, for example, to do fraud detection for a bank. We cannot do that in batches. We have to do it in streaming, in real time. So when designing data architectures or data engineering systems, we have to have that in mind from the early beginning in the design first. We also to keep in mind that we have to develop data into different formats during the transformation phase in the pipelines. We can go from simple object data structures into maybe a graph when dealing with social network, for example, so social marketing network as well. We could also maybe say that for this specific problem, we need to format our data into JSON or an XML or just plain text and so on. So having those skills upfront and probably developing small libraries and functions that are ready to be used whenever needed is very important. And of course, the ability to handle erroneous data and data quality check as well. That is also important. And the last shift in the mindset is data versioning. Before, versioning was only for the source code. But now, even the data, we have to keep different versions so that we can roll back to a state where it was working properly whenever we have a problem. So to allow to increase the availability in a case of an incident.
Wow, that sounds like a really interesting thing. Data versioning. It feels like something that could have its own episode.
Indeed.
Yeah, I think my last question here is for someone who's going into a leadership role within uh, data engineering, what kind of advice would you give them in terms of where to start, how to get a good handle on things, and how to build sort of high performing? I know you mentioned a lot of things, but in terms of just direction on which way to go, what kind of advice would you give to them?
Because they're already contemplating to go into management, it means they have some decent engineering experience. So they are somehow already, they've been technical already. So I'll advise them to focus more on the architecture, especially in the context of the cloud. So they need to think of the architecture in terms of platform as a service and infrastructure as a service, as well as software as a service. Because right now, if you want to run smoothly data engineering team, you should never make a mistake to try and use out of commodity hardware to build your infrastructure. You'll waste a lot of time and you'll always be in big trouble and missing important deadlines. So I always advise to use managed services as much as possible in the cloud, whatever, whether it's Azure or AWS or GCP or WCNP, as long as it's managed services, that should be the first step. So understanding the infrastructure, how does infrastructure work? What are the main infrastructure that empowers data engineering? More specifically, things like Hadoop, MapReduce, understanding how to use like Solar, and understanding how to use like Google Data Proc and so on. The infrastructure level is very important. And if you are in the data analytics space, understanding infrastructure such as Apache Druids is also very important. So not just understanding the technical side of it, but the conceptual is more important because concepts remain, but the technicality will change over time. So if you understand only the technicality of it, in the next 2 years, a new version will come out. So which means you won't be able to catch up. But if you understand the concept will always be the same. So you'll always be able to catch up without making much effort. So that's the first level. The second level is to invest a little bit of time into becoming a little bit, not too much, just a little bit hands-on. Like when we say about implementing unit tests in a data pipeline, how does it look like? As a manager, we need to know that implementing integration tests, implementing quality checks, implementing alerting system, be able to run performance tests process and so on. So as a manager, we need to understand how those things work so that we can better support the team because we are not HR managers, we are engineering managers. So we are expected to provide technical leadership as well as people leadership. So we cannot provide technical leadership if we don't understand how things work, if we don't know the details about how things work. So investing in architecture and in some end-on activities about daily work that's being done by data engineers will set up the person who's trying to become a manager for success.
Thank you so much, Baron. I think from today I'm going to call you Baron of Data. So thank you so much for your time and for your insights. It's been really helpful. I'm sure that the audience have really enjoyed your insight and your knowledge. So yeah, thank you very much, and have a good day and a good weekend.
Thank you very much, Hugo. Have a good day too, and
Okay,
a good weekend.
bye.
Bye bye.